So let's start. Today we are going to discuss the bi-weekly contest 178 of LeetCode. We are going to see the solution for all the questions. So let's start with the first question. So let me check that recording is yes. So what is the first question? The first question says that you are given an integer array nums. Return an integer denoting the first even integer. Earliest by array index that appears exactly once in nums. If no such integer exists, then return -1. An integer x is considered even if it is okay. So what you are given is uh yeah. So you are given an integer array nums. Okay. Uh, suppose can be anything 3, 5, 4, 8, 6, 4. Okay, so you are given an integer array nums. So what you need to find is you need to find the first element, like first element by index, first even element by index, first even element by index that appears once. The first condition is it should appear once in the whole array. Should appear once in the whole array. Okay. The second condition is it should be even. As I have written even element, it should be. It it should be even. And the third condition is like whatever are the elements that follows these two conditions, we have to return the first element. It should be first element. Okay. So let's see in this example. See like what are all are the even numbers. This number is even, this number is even, this number is even, and this number is even. Okay. So how many of them appear only once? See, 4 appears 2 times. Okay, so this we won't consider. What else are the numbers? 8 and 6. 8 and 6 both appears 2 times. Which of them is the first one? 8 is the first one. So we have to return 8. Okay. We don't have to return the index. We have to return the element 8. Okay. So this is what you need to do. Let's take another example also. So suppose 3, 4, 3, 4, 5, 6, 9, 6, 8, 4, and suppose 2. Okay, so see here. What all are the numbers that are even? 4 is even, 6 is even, this 6 even, 8, 4, 2. Okay, these are all the even numbers. Now, which of them appears only once in the whole array? Now see, 4 appears twice here and here. So 4, we won't consider 4. Okay, 6 appears twice. We won't consider 6. Now again, see 8 and 2 appear once. Okay, so which of them is the answer? 8, since it is the leftmost element, like the first element that is appearing. So answer is 8 over here. Okay. So how will approach the question? Actually, there were many methods because the constraints are small. Like the constraints are, see, the array length is 100 and nums of I is also up to 100. So there are various ways like which you can implement. But let me show you like what I have done. So you can do anything like any kind of brute force will work. Like this n square and cube, all of them will work. But let me show you what I have done. So what I have done was like I have taken two maps. I have taken two maps, MPP1 and MPP2. So one map is used to store the frequency of elements, and another map is used, to store the first index of each element, like first index of each element. So what I would be doing is, in my first pass, let me recopy the array 3, 4, 5, 6, 3, 5, 6, 9, 6, 8, 4, 2. So see, what I will be doing is in the first array, like in the frequency array, I will keep on, iterating over the array. So and store the frequency, like three appear once, three appears once, four appears twice, five appear once, and similarly six appears twice, eight appears once, and two appears once, two appear once, and nine appear once. Okay. So in my first pass, I will be storing this, like the frequency of all the elements of nums array, and I will be storing the first index of each element. Like I will be storing like three appears on the zeroth index, okay, and this two appears on which index? 0, 1, 2, 3, 4, 5, 6, 7, 8, eighth index. Four appears on the first index. Uh, Just like this, you can store all of them. Okay. Now, in your second pass, in first pass, I have populated both my MPP1 and MPP2, which stores the frequency and the first index where each of the element is appearing. Okay. This I have stored. So, in my second pass, what I am going to do is I will iterate over this and check like whether I will iterate over this whole array. You can iterate over the whole array, or let me see what I have done. See, or you can iterate over the MPP also. You can iterate over the array or you can iterate over the MPP. Okay. So what you are going to do is you need to find the minimum index because you have to find the leftmost index. You have to find the minimum index. Okay. So either you can iterate over nums or you can iterate over MPP also and keep on taking the minimum. So what I have done here is I have taken the second approach, iterate over MPP and find the minimum index. Find the minimum index. So what I will do is I will iterate over this whole MPP array. Okay, and what I'll do, I will check first of all, I will check like whether this number is even or not. First, check even or not. Okay, if it is even, then check. If it is even, then check whether it appear once only or not. Once appears once or not. Once or not. Okay, and if it is appearing once, then you have to take the minimum of this index and the answer index. Okay, and the answer variable. Minimum of index and answer. Okay. So see here, what we'll do, like let's see the MPP array. Like let's see this array. Okay. So first of all, I come on to okay, and I see like is it even? Yes, it is even. Okay. I see yes, it is even. And does it appear once? Yes, I have stored the frequency. It appears once. And what is the index? Initially, my answer variable would be containing a large value, suppose 200, because the size of array is 100 only. So we can take answer equal to 200. So I have taken answer equal to 200 initially. So see, I come on first, like this 2. So what does 2 contain? Does 2 is 2 even? Yes, 2 is even. How is it appearing only once? Yes, it is appearing only once because it has frequency of 1. Okay, and what is that index? So its index is 8. So we will take minimum of 8 and 200. Okay, so answer will now contain 8. Okay, now we'll move forward. Now see 3. 3 is odd. Okay, so since it is odd, so we'll continue because we wanted to check only even numbers. Okay, now we come on 4. Is it even? Yes, it is even. Does it appear only once? No, it is not appearing only once. It is appearing twice. So we'll ignore this also. Okay. Now 5. 5 is odd, so ignore this also. 6. 6 is even, but it is appearing twice. So ignore this also. Now we come on 8. 8 it is even and it is appearing once. Okay, so we'll take minimum of this one, like the index of 8. What is the index of 8? This is the frequency. Okay, this is not the index. We have to take the minimum of this index. Okay, because we need to find the leftmost index. That is why we are taking the minimum of index. So what is the index of 8? 0, 1, 2, 3, 4, 5, 6. 6 is the index. Okay, 6 is the index. So yeah. So we'll take minimum of 6 comma 8. So answer becomes 6. Okay. Now 9 is odd, so we'll continue. Okay. We'll ignore it. So what is the answer? Now answer variable stores 6. So what is the 6? This is the answer index. Index of element. But we need to output the element only. So what we'll do, we'll simply print nums of index, this nums of ANS. Okay, so this stores the answer. Why? See, answer was this sixth element. What is the sixth element? 8. And since we know 8 was the answer, so we'll just print nums of index. Okay, so let's see the code also. So see, I have done MPP and MPP2. MPP is storing this your frequencies, and I am checking like the MPP2 is storing the indexes of elements. Okay. Now see, if element is, even, and if already we don't have this element, then only we'll update it. Okay. So actually this condition was not needed. Like even if you don't write this condition and these both of these condition, even if you have not written both of these if conditions, then also it would work. But yeah, it is good this way also. So see, I am storing this if this element has not already appeared, if this element has not already appeared, then store its index, because we have to store the first index. So this is what I am doing here. Like if mpp2 dot find nums of I is equal to mpp dot end, so like this means that this element is appearing the first time. If this element is appearing the first time, we have stored its index, so this is first index. Okay, now in mpp I am checking if this it dot second is greater than equal to 2 or it is odd, then you have to continue. Yeah, like you have to ignore it. Otherwise, just take the answer, just take the minimum of answer and the index, the first index where this element was present. Okay. So now the answer variable stores the index of the answer. Like because we have to return the element, we have to return the element. Like see here, 2 is the first element. 2 is the first element, which is, the leftmost also and following all the conditions. So our answer variable will contain the index. So in order to print the value at that index, we just have done a return nums of ANS. Okay. So this is what we are going to do. This was an easy question. Now let's see this question also. Uh, this is also another easy question. Actually, it is proper brute force only. Like you have to do what it says. So let's see what it says. You are given an integer array nums of length n. Okay. Construct an array prefix GCD where for each index I, let mx of I equal to maximum of like prefix maximum. Mx of I is the prefix maximum, and prefix GCD of I is equal to GCD of current element and maximum of this maximum of the array, like the prefix maximum. Like prefix GCD is the like your prefix GCD, I believe it is the yeah, I think it is maximum of all the prefix elements and current elements GCD. Okay, maximum of all elements, maximum of all previous elements and current elements GCD, and yeah, and you have to take its GCD and you have to construct a prefix GCD array. Okay, and after constructing a prefix GCD array, what you have to do? You have to sort it in ascending order, like non-descending order. So or this ascending order only. And you have to form pairs by taking smallest unpaired element and largest unpaired element. Repeat this process until no more pair can be found. Another important thing is you have if n is odd, the middle element is ignored. Okay, it remains unpaired and it should be ignored. And finally, you have to do sum all the elements in this newly formed array. Okay, like the newly formed pairs. So let me show you what it is trying to say, because you have to do a lot of things. Like it is appearing like you have to do a lot of things, but the code is easy only. So let me show you. So it says like you have a nums array, nums array. You have a nums array. It can be anything. Let me say example 3628. Okay. Let me expand it further so that you can get a better understanding. So 3628. Okay, it was 9, and what else? 9 was 14. Okay, and 16. Okay, so suppose this was your nums array. Now what you have to do is, first of all, let's take the prefix maximum array. Create a prefix maximum array. Okay, so 3. Now what is the maximum of fill here? Fill here 6. Fill here 6 again. 8, 9, 14, and 16. Okay, so this is the prefix maximum array. And let's construct the prefix GCD array. I hope it was prefix GCD only. Prefix GCD. Yeah. So we have to construct the prefix GCD array. Now, what is the prefix GCD array? You have to take the GCD of these two elements. Okay. So you have to take the, GCD of current element, like the current element you are standing, and the maximum till current element. Okay. So this is stored, the maximum till current element is stored in the prefix maximum array. Prefix maximum array. Okay. So just take the GCD of these two values, 3. GCD of these two values, 6. GCD of these two values, it is 2, I think. Okay. Uh, okay. I think. Yeah. So 2 and 6. Okay. The prefix, it is of 8. Okay. 9, 14, and 16. Okay. Suppose this was your array. Okay. Now what you have constructed the prefix GCD array. Now what was the next step it was asking to do? It was asking to sort, I think. Yeah. So first of all, we have to sort this array. Now let's write it after sorting. What does it become? 2, 3, 6, 8, 9, 14, and 16. Okay. I think this is the correct. Yeah. 6 was twice, I think. Uh, or not. 6 and 2. Yeah. So it is correct. So I have sorted the array. Now see, this is after sorting. After sorting, your array becomes this. Okay, now what you have to do is you have to pair the elements. Like first of all, you have to pair the smallest and the largest element together. Now, what does pairing mean? You have to always, take the first non-paired element and like the smallest non-paired element and the largest non-paired element, and you have to take the GCD of both of them. Okay. So what is the smallest non-paired? Since currently all are non-paired elements, so let's take the smallest and largest non-paired element. So this is the smallest non-paired element and this is the largest. So let's pair them together. Okay. So what does pairing mean? Now you have paired them. So you have to, calculate GCD of 2 and 16. What is the GCD of 2 and 16? It is 2. And store and add it to your answer. Okay. So initially your answer was 0. Now you have to add plus 2 because you have to add GCD of these two elements. Okay. Now they become paired. Now what is the smallest unpaired element and largest unpaired element this time? So it is 3 and 14. So take them, pair them. Now what is the GCD of 3 and 14? It is 1. Okay, so let's add 1. Okay. Now take again the smallest unpaired and largest unpaired. So calculate GCD of these two. What is the GCD of these two? GCD of 6 and 9 is 3. Okay. Now 8. 8 is single. And it was said like if there was n was odd, like the array length was odd to 1, 2, 3, 4, 5, 6, 7. Now 7 elements. So if the length was odd, you can leave the middle element. Okay, because single element can't be paired with any other element and you can't pair it with itself. Okay, so leave it as it is. So what is your final answer? Your final answer is 3 plus 1 4, 4 plus 2 6. Okay, this is your final answer. Okay, so this is what you have to do. First of all, what was our steps? First of all, you have to calculate the prefix maximum, and then you have to do the GCD of nums and the prefix maximum array. Okay, and after constructing the prefix GCD array, like the prefix GCD array was made, after constructing the prefix GCD array, you just have to sort it. And you have to start pairing just like this only, like the smallest element and the largest unpaired element, take them together, calculate their GCD and add them to your answer. And if, finally, like your I and J, like if the n is odd, you have to leave the middle element as it is. Okay. So this is how our approach will be going to look like. So if you want, like, let me give you another example also, like an even example. So 3628, let's take this time 3628 only so that you can check your answer also. So nums equal to 3628. Okay, so let's consider the maximum array, like the prefix maximum. Prefix maximum is equal to 3668. Okay. Now what is the prefix GCD array? take the GCD of these two. So 3, 6, 2, and 8. Okay. Now let's sort the prefix GCD array. So what does it become after sorting? 2, 3, 6, and 8. Now let's start pairing. So 2 and 8, what is their GCD? 2. And 3 and 6, what is their GCD? 3. So 2 plus 3 is equal to 5. I hope 5 is the answer. Yeah, so 5 is the answer. So this is what we are going to do. Uh, Now let's see the code also. This is exactly like what I have said. Like we'll do exactly what I have said. Okay. First of all, the nums array, calculate the prefix maximum. Like I have not calculated the prefix maximum, but just I have, kept a maxi variable that is storing the prefix maximum because this array actually it is not needed. Only we have to calculate the prefix maximum. So I am storing it in a variable only because this and calculating the prefix GCD side by side. Okay. So let me show you the code. So initially I have this HCF array is the same like your prefix GCD array. I have given it the name HCF array. Okay. So int maxi like the maxi variable just as I was saying. So I am calculating the prefix maximum like the maxi variable is storing the prefix maximum. Okay. So I am at each step I am calculating maximum of maxi comma nums of I. So this gives me the maximum over the prefix. Okay. And since HCF of I was GCD of current element and the prefix maximum element, so I'm calculating the HCF array like this. This is the prefix GCD only. Okay. So I'm storing the prefix GCD. After storing it, I am sorting the whole array. Okay. And after sorting, like I have used two pointers, like one will point to the start, another will point to the left, like to the right, the largest element, and storing it in the answer variable. So at each step, I am doing, pairing the smallest unpaired element and largest unpaired element, and calculating the GCD of both of these elements and doing I plus plus and j minus minus. Now, how is the odd case handled? Like I have the in the while loop, I have put the condition while I is less than j, because if I is equal to j, then also we don't have to pair it and we have to ignore it. So that is why I have not put an I less than equal to. Okay. So that is the reason. I hope you are clear with the explanation. Like this was also easy question. Like you were exactly given what you have to do in the question itself. Okay. So you don't need to think anything. Just, do what is asked in the question. So this was also a very easy question, I believe. Uh, yeah, I don't know why they have given it a medium tag. It was an easy question only. So let's see the third question. Like, what is the third question? It says the minimum cost to equalize array using swaps. Okay. So you are given two integer array nums1 and nums2 of size n. You can perform the following two operations any number of times on these arrays. Swap within the same array, like choose two indices I and j. Then choose either to swap nums1 of I or nums1 of j, or nums2 of I and nums2 of j. Like, what is the first operation saying? You can, swap within the same array. Any two elements within the same array, you can swap with free of cost. Like this is written, this operation is free of charge. Uh, yeah. And what is the second operation? The second operation says, like you can choose any one index. You can choose any one index and then swap the index like the values at nums1 and nums2. Okay. So, like the operation one is saying you can, swap any two elements within the same array using zero cost, and the second one says you can swap the numbers between the two arrays, but this will incur a cost of one. Okay. Finally, you have to make nums1 and nums2 identical, and if this is not possible, return -1, and otherwise you have to do it like if otherwise if it is possible, then make them equal using minimum cost. You have to output the minimum cost. Okay, so this is the question. So now let me explain you the question using some example first, so that you get a better understanding. The examples are too trivial, I suppose. So let me take a bigger example. So it can be the example. Suppose nums1 equal to 10, 10, 20, 10, 15, 15. Okay. And nums2 equal to 20, uh, 20 and suppose 20, 20, and 10 and 15, 15. Okay. Suppose this is the case. Like you have these two arrays. Now, what you have to do is you have to make the elements equal. Like you have to make nums1 and nums2 equal using minimum cost. And you are allowed to do two kind of operations. You can either, swap within the same, like in nums of one, like in nums one, you can choose any two elements and swap them. This will incur a cost of, 0. Like you can swap this 10 and this 20, your cost will remain same. Like your cost will remain as it is because this operation doesn't cost you anything. Like swapping 10 and 20 in the same array won't cause you any cost. Okay. And suppose you want, what is the other kind of operation that you can do? You can swap these two, like this 10 and this 20. This will incur you a cost of 1. Okay. So what you have to do is you have to make these two arrays equal and using like give the minimum cost, like give the minimum cost. Okay. So let's see what we can do. Uh, so first let me give you the answer for this particular question, like how you can, do this. So see, 10. We have a 10 here, so we want to make a 10 here. Okay, so I will check like whether do I have a 10 anywhere in this whole array, because I can put, like I can like I can put a 10 here. Why? Because putting any 10 here, like swapping this with any 10 in this array, like in the nums2 array, if I have any 10 present, and if I swap it with this value, like this 20, then uh, it will not incur me any cost because this 10 is in this array only. Okay, so I will bring this 10 over here. So what does it become? The array, like the nums2 become 10, 20, 20, 20, and 15, 15. Okay, now let's see. See again. Now this is your nums2 array, and these two elements became equal. Okay, now let's see this 10 and this 20. So do I have any 20 over this whole array? Like, do I have any 20 over this whole array? No, I don't have any 20. So what I need to do? So, and do I have 10 in this array? Like in this array, do I have any other 10 apart from this? Yes, I have this 10. So what I need to do is I need to bring this 10 down. I need to bring this 10 down and put it over here. Like in short, I will have to put my 10 over here. I have to put this 10, like this 10 over here. Okay, this is what I need to do. So how will I do this? Like, see, this is the fourth element. Fourth element. And what is the fourth element here? 20. So I will swap these two, like this 10 and this 20 I will swap. This will incur me one cost. So let me write a cost variable here. Currently your cost was 0. Now I will swap this 10 and this 20. Okay, so what does nums1 become? Nums1 becomes nums1 becomes 10, 10, 20, 20, 15, 15. Okay. And what does nums2 become? Nums2 becomes 10 because 10 we put here 10 by swapping, and now 20 here, 20 here, and we have swapped 10, 15, 15. Okay. So and this gave me a cost of +1 because I have swapped these two elements. Okay, 10 was initially in nums1 here. Okay, so this gives me one extra cost, like one extra cost I incurred. Okay, and now let's see. And still this 10 is not equal to 20. We were here, and still this 10 is not equal to 20. So what I can do, simply swap these. You can simply swap these. Okay, because I have a 10 in this nums2 array, I can clearly swap them. Okay, so now what does nums2 become? Your new nums2 become 10, 10, 20, 20, 15, 15. Okay, let me, yeah, so this is, so now your 10 and this 10 becomes equal. This 20 and this 20 is equal. This 20 and this 20 is equal. 15 and 15 is equal. 15 and 15 is equal. So how much is our total cost? 1. So finally, you can check all other combinations. The maximum cost, like the minimum cost you will get is 1 only. Okay. So this is the answer. So how, what to, like how you can think, like this was a, how will you, do this all in this, in actually the originally, in the original array? Like, It always won't happen like, you will check, like suppose a 10 comes and you see here 20. So first of all, you will check whether a 10 is present in the front or not. And if it is not present, you have to take any one of the 10 from this nums1 array only, and you have to put it over here. So it will be a very hectic task. So let's see, like let's observe something. So let's write some of the observation. What is the first observation you will say? Like when is the answer not possible? Like when is the answer not possible? What does not possible mean? Not possible mean that nums1 can never be equal to nums2. Like whatever operation you do, nums1 can never be equal to nums2. Okay, so when will that happen? See, in order to make nums1 and nums2 equal, all of the elements should have an even frequency. Like nums1 equal to nums2 only when all elements have even frequency. Correct? Why so? See, even if like I'm talking frequency, like not an individual array, like sum of all the element. Like, see, nums1 would have some occurrences of a particular element. Like, see, suppose 1, 1, 2. Okay, and nums2 equal to suppose 2, 2, 1. Okay, so what is the frequency of 2 here? Frequency of 2 is 3. Frequency of 1 is also 3. I'm talking the combined frequency, like in this array and in this array. The sum of frequency of 2 in this array and sum of frequency of 2 in this array. Now see, since 1 is appearing 3 times, even in the worst case, if I arrange them like this, okay, one of the 1 will always remain unpaired. Suppose if 1 appeared 5 times, 1 appeared 5 times. Okay, I will pair like them like this, like 1, 1, 1, 1. Okay, like this is nums1 and this is nums2. Okay. Now again, one of the 1 will always remain unpaired. One of the 1 will always remain unpaired. Now, how will I pair this? Because I have only 5 ones, 4 ones are already paired among themselves. One of the 1 will always remain unpaired. Okay. So that is one of the case, like not possible case. Like we have figured out the not possible case. Not possible case would be, when this like when any of the element, when any one of the element, even any one of the element has odd frequency. Okay. So when any one of the element will be having odd frequency, then it won't be possible to, combine them, like to make them equal. So this is the not possible case. Okay. And what is the other case? Like when now remains the possible case. Now in possible case, I have to calculate the possible case. I have to, calculate the minimum cost. Possible case, minimum cost. This is the case that remains. So see, suppose like uh see here. Suppose one was appearing total 8 times. Okay. Suppose one was appearing 8 times. So how will our arrangement look like? 1 1 1 1 1 1 1 1. Okay, so definitely, since now we know that all of the frequencies of all elements will be even, so suppose one was appearing 8 times, so definitely we are sure that 4 times one should appear in nums1 and 4 times nums2, one should appear in nums2. Why? And they should be on the same index also. Then only the pairing is possible. It won't happen like 6 ones are present in nums1 and 2 ones are present in nums2. That won't happen. In order to make them exactly equal, then nums1 and nums2 should have half elements. Okay. So nums1 should be 1 and nums2 should also have, half elements. So what is half of 8? 4. So 4 times 1 here and 4 times 1 here. Suppose 2 was appearing 6 times. Suppose 2 was appearing 6 times. So in nums1, 2 should appear 3 times. And in nums2, 2 should also appear 3 times. Okay. So this is fixed. Now we have got like how many times a particular element should appear in each of the arrays. Okay. So now we know that. Suppose suppose a case like this happens. Suppose a case like this happens, like 2, 1, 2, 1. Okay. And 1, 2, 1, 2. So see this case. Now see 2 is appearing 4 times, 1 is appearing 4 times. Now 2 should be present, like 2 should be present in this nums1 array. So nums1 array should contain two twos. Okay. And nums2 array should also contain two twos. So this is satisfied. Nums1 array should contain two ones. Okay. It is containing two ones. And nums2 array should contain two ones. Okay. It is containing two ones. Now see here. Rearranging like the nums1 array and nums2 array contain the correct frequencies of element. Like the frequency of each element is correctly present in nums1 and nums2 array. Only their rearrangement is to be done. The rearrangement cost is zero. We know that the rearrangement cost is zero because we can swap these elements, and still we have zero cost. So only thing like rearrangement has zero cost. Rearrangement equal to zero cost. The only cost we are incurring is to make the frequencies correct. Frequency cost. Frequency correction cost is equal to total cost. Okay. So all you need to do is you need to make sure that the frequency of all the elements, like the frequency of all the elements should be present correctly. Rearrangement can be done. Rearrangement can be done with zero cost. You only need to take care of, frequency correction cost. So this is what was the main idea. Like, don't think of rearrangement. If the frequencies are correct, like, see, like just as you saw, like frequency of 2 and frequency of 1 was correct. So just you need to, make frequency this rearrangement. Like we have to do only rearrangement here, and we know rearrangement can be done with zero cost. So only extra cost, like only cost we are incurring, that is the frequency correction cost. Okay. So just take care of this cost. Okay. Now how will we do frequency correction? So see, what I will do is, I will calculate how many times a particular element is present in nums1 and how many times it is present in nums2. Okay. So I will calculate individual frequencies, like how many times in nums1 and how many times in nums2. Okay. So, and what is its total frequency? Like it is nums1, like how many times it is appearing in nums1 plus how many times it is appearing in nums2. That is the total frequency. But I will calculate individually, like how many times it is present in nums1 array and how many times it is present in nums2 array. Okay. I will calculate like this. Okay. And in order to make their frequency correct, half of them should be present in nums1 and half of them should be present in nums2. So suppose, like in nums1, a particular number x, suppose some x was appearing 2 times in nums1, and in nums2 it was appearing 8 times. Like, this is the frequency. X is appearing 2 times in nums1, okay, and x is appearing 8 times in nums2. So what is the total frequency? Total frequency is 10, okay. And what is its half? 5. So 5 should be present here and 5 should be present here. Okay, so how many swaps? Like how many swaps between nums1 and nums2 do I need to make? Only 3 swaps. Why? Because if I make 3 swaps for any two elements here, like if I make any 3 swaps here in this nums1 array, then definitely I will get 5 ones here and 5 ones here. Like wherever, like see here, something I'm saying something like this. Suppose x, let's take x equal to 4, suppose. So x equal to 4, 4, 4, and 4, 4, 4, 4, 4, 4, 4, and 4, suppose 1, 2, 3, 4, 1, 2, 3, 4. Okay. And here it was 5, 5, uh, suppose 5, 5. Uh, suppose 5, 5. Okay. Suppose only two elements are there, 4s and 5s. Okay. This is your nums 1. This is your nums 2. Now see for 4, like x equal to 4. Two fours are present here and eight fours are present over here. So I need to, transfer three fours from here to here. Okay, so how I can do that? You can take any three fours apart from these, like these are already paired. So take any three fours, like one, two, three, okay, and swap them. So see, what does the array become? 4, 4, 5, 4, 4, 4, 4, 4, and 5, 5, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And what does this become? 2, 3, 3, yeah, 5, 5, 5, no, 5, and here it is 4, was not swapped, however, it is swapped, and it is not swapped, 5, and 4, 4, 4. Now, okay, now let's see. So, now see here, how many fours were, total fours, how many fours total fours were present? Total 10 fours are there, like see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so total 10 fours are there. Like, yeah. And so how many should be present in nums one? Five should be present. Like, is there five? One, two, three, four, five. Yes, five are present. And how many are there in nums two? Five should be present. So one, two, three, four, and five. Okay, so here also five are present. So now we have made the frequencies correct. Only thing is to be done is the rearrangement. And rearrangement cost is zero. So in order to make four correct, I only took three cost. Okay, because rearrangement cost is zero and frequency correction cost was how much? See, two times it was here, eight times it was here. So you can, simply do, like, you have to calculate the total, divide by 2 and subtract it from this. Like, see, 8 plus 2 is 10, 8 plus 2, divide by 2. How much is it? 5. है ना? And like 5 should be present in nums 1 and 5 in nums 2. And, simply subtract it from one of them, like either the nums 2 frequency or nums 1 frequency. Okay, and take the absolute. So see, 5 minus 2 is 3, and 5 minus 8 is minus 3, and absolute of it is also again 3. So, only 3 costs will incur. So in this way, you can, easily get how much cost it will take very fast. Like, simply, calculate the total frequency, divide it by 2, and subtract from original frequency in one of the arrays. This will give you the frequency this will give you the cost for correcting that particular element. So 4 correction took you 3 cost. Correction of 4 gives you 3 cost. Another thing you can observe over here is initially 5 was also incorrect. See, here 1, 2, 3, 4, 5, 6. 6 fives were present. Okay. Now let's see the case for 5. For 5. Nums 1 contained 6 fives and nums 2 contained 0 fives. Okay, so what is the total frequency? It is 6 plus 0, 6. And for correction, what was the formula that we just saw? It is 6 plus 0 upon L by 2. Okay, so 3. And I told you have to subtract it from here. So what is the cost for correction of 5? 3. Okay, so for correction of 5, you also got 3 cost. For 5, cost is 3. Okay, and 4 also for cost 4. But if you see, once you applied the operation for 4, once you applied the operation for 4, 5 automatically got correct. Now see here, 5 are 3. Initially, 6 fives were present in nums1. But when you applied the operation, only 3 fives were present in nums1 and 3 were present in nums2. Why? Because 4 would have been, 4 would have been swapped with some element. Like when 4 came down, some of the element must have gone up. Okay, so automatically the answer was half. Like the answer was half of the total value. Like for 4, the answer was 3. For 5, the answer is 3. The total sum of it is 6. But the answer is 3 only. Answer is it's half only. The sum of, correcting all the individual values, you have to take its sum and divide by 2. That is the answer. Why? Because, When 4 came down, it will always happen. Like when 4 came down, something will go up definitely. And that was also incorrect. So definitely, when we are doing one swap, we are correcting two of the elements at the same times. So one swap corrects two elements. That is why, calculate the total, total swap for all the elements and divide by two. Total swaps for all elements on 2 is equal to the answer. Okay, so this is your answer. Total swap for all elements divide by 2 is your answer. Okay, because because just as I told you, one swap within the two arrays, is correcting two elements. So that is why the total answer is total swap required for all distinct elements. It's a distinct for all distinct elements divide by 2. Okay, so that is the answer. Now let's see the array, see, MPP1 is storing the frequency of elements in nums1 and MPP2 is storing the frequency of element in nums2. And this set stores all the distinct elements. Okay, it is for the sake, for calculating, since we have to calculate total swap for all distinct elements. So first of all, I am storing the distinct elements also. That is why I have taken a set. Okay, and we are populating them here. Finally, we are first of all checking the condition for -1. What is the condition? Like if, any particular element, like since the set contain all the distinct elements present, I am checking if the total frequency of any of the element is odd, then simply return -1. Okay, and if it is not, then definitely some answer is possible. So I am calculating the operations here. So what I am doing is, again, I am iterating over all the distinct elements. I am iterating over all the distinct elements and I am calculating the total frequency by 2 and subtracting it. See, you could have done like MPP1 of IT minus half absolute, but what I am doing is like, see, one of the elements, like as we saw, like if nums1 frequency, like some element x had nums1 frequency 2 and nums2 8. So I am calculating the maximum of it. What is the maximum? 8 minus 5. Okay. So this is that part, like maximum of both of the frequencies minus half. So this gives me total operations. And finally do operations divide by 2 because I told you, due to this thing, like one swap corrects two element. That is why, we have to do the half of it. Okay, so that is the reason. Like if you have, thought of like doing the operation physically, like if you have thought of, like I told you in the brute force approach, like where is the brute force? So just where it go? Yeah. So if you have done like this, like physically swapping the elements, if you have physically thought of physically swapping the elements, then it would have caused you a lot more problem because first of all checking like whether 10 is present in nums2 array or not, then checking if it is not present, then you have to check for 10 in this array and check that 10, like it would have been very difficult. You can think of that because doing it physically was very much difficult, and maintaining the arrays. So that is why this is the easier approach. Like the main idea was that total cost is only the frequency correction cost. Okay, the rearrangement cost is zero. So that is the reason. So yeah, this was also easy question, I suppose. The only thing you have to do was just observe instead of doing the operations physically. Just observe what is happening. So yeah, that's the case. Now let's see the last question. What is the last question saying? So it says like count fancy numbers in a range. So you are given integers L and R, and integer is called good if its digits form a strictly monotone sequence, meaning the digits are strictly increasing or strictly decreasing. All single digit letters are considered good. Okay. An integer is called fancy if it is good or if the sum of its digit is good. So, okay, and return an integer representing the number of fancy integers in the range L to R. So, and you are given the definition of strictly increasing and strictly decreasing. So, let me first tell you what the question says. The question says you will be given some L and R. Okay, L and R. And what you need to do is you have to find first. Let me tell you what is strictly increasing. What is it talking about strictly increasing or decreasing? What see, it is saying that a strictly increasing number or a sequence, like it is saying sequence of number only. Like what is the strictly increasing number? So number will called strictly increasing if all of the digits are in this order. Like the first element is always less than the second element is less than the third element. It can't be equal, like 1 2 3 3. This is not, strictly increasing. So for strictly increasing, it should be, increasing only. Equal is not correct. So first element should be like first index, like you can say index only, like first, like this digit should be less than next digit. This digit should be greater, like should be less than this digit. This digit should be less than this digit, and so on. Okay. What is strictly decreasing? Similarly, you can think strictly decreasing. It would be 5, 4, 1. Okay, so this is also strictly decreasing number. So 5 is greater than 4, 4 is greater than 1. So this is a strictly decreasing. So what you have to do is you have to count in this range, like in L2R, how many are, strictly increasing or decreasing. Like these two numbers are called good. Like if any number is either strictly increasing or strictly decreasing, it is called good. Okay. So in L2R, you have to calculate the number of good integers. Also, plus like good integers in L2R. Okay. Like it is also defined, I think, a some term as fancy. What is, I think it is done. Yeah. So when is an integer called, like when is a integer called fancy? It is called fancy if either itself is good, if either if either it is good, or some of its digit is good. Okay. So you have to calculate the number of fancy numbers between L2R. Okay. So first let me explain you what is a fancy number. So let me explain you. See, this number 118. See, this is not a strictly increasing number, neither it is a strictly decreasing number because you have 1 over here present. Okay, so it is not strictly increasing, neither it is strictly decreasing. But if you calculate the sum of its digit, what is the sum of its digit? 10. Okay, 8 plus 1 plus 1. Okay, so 10. But 10 is a, good integer. Why? Because, 1 0, it is forming a decreasing sequence, so it is good. The number itself was not good, but its sum is good. So it is, so 118 would be called a fancy number. Why? Because the fancy number state either the number itself is good or the sum of its digits should be good. And here the number itself was not good, but its sum of digit was good. So that is why 118 is a fancy number. Okay. So similarly from L to R, you have to calculate the number of fancy integers. Okay. Like how many fancy integers are present. So this is what you need to do. So what is what is the requisite, I would say, for this question? Like, first of all, let me tell you the observation before even going for prerequisite or anything. So, see, since let's see where till where the numbers are going. See, L and R can go from 1 till 10 power 15. Okay. So, L and R can vary from 1 till 10 power 15. So, iterating over them is not possible because, 1e15 operations we can't do. Okay, so what should be the approach? Like since 1e15 are present, so what can we do? Now let's see the last number that can be formed that is strictly increasing or decreasing. See, the last number that can be formed is can be of this order, like 1, 2, 3, 4, 5, 6, 7, 8, 9, or 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, because after that the digits are finished. Like we can't write 10 here because 10 is not, it will be considered 10 only. Okay, so the last number, that is the maximum digits, like the maximum digit number, that is fancy. It will be this only. Fancy can be anything. but the last good integer, like the good, it itself should be good. So see, the largest sequence you can form is of this only, like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total nine numbers. Okay, so total nine digit. So at max, a nine digit number can be good. Not fancy, it can be good. Okay, a nine digit number can be fancy, good. Okay, so and how many nine digit numbers can be good? Only two numbers. So only two nine digit numbers are good. Okay. Now let's check for eight digit numbers. If you check for eight digit numbers, first let's check eight digit numbers that are good. Eight digit numbers that are good. Let's check what all are the numbers. So see. Also you should know that 10 digit, 11 digit, 12 digit, any other, greater than 9 can't be ever be good because, after that 9, what you will be going to put in order to make it increasing. We have to put 10, but 10 is itself considered 1 0, so 9 is greater than 1. So that is why the maximum digit, like the maximum digited number could be only 9 digits. So let's now see the 8 digit numbers that are good. Okay, so 8 digit numbers. Let me write first increasing one, increasing. So 1, 2, 3, 4, 5, 6, 7, 8. So see, this is 8 digit, or 1, 2, 3, 4, 5, 6, 7, 9. This can be also. Okay, what else? It can be 1, 2, 3, 4, 5. Uh, Only these two are possible. Okay, only these two are possible. Nothing apart from them is possible. Because, if you put any other thing like, uh, no, other, this can be also possible. 1, 2, 3, 4, 5, 6, 8, 9. This is also possible. Okay, what else? Uh, 1, 2, 3, 4, 5, 7, 8, 9. This is also possible. Okay. So in this way, you will get several numbers. But even if you think only one digit is allowed. Okay. So at max, like how many numbers can we get? Let's think about that. Another number can be 1, 2, 3, 4, 6, 7, 8, 9. Or uh, another can be 1, 2, 3, 5, 6, 7, 8, 9. Or 1, 2, 4, 5, 6, 7, 8, 9. Or 1, 3, 4, 5, 6, 7, 8, 9, or 2, 3, 4, 5, 6, 7, 8, 9. Only these numbers are possible. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so only 9 are possible that are increasing. Similarly, 9 would be possible that are decreasing. So 18 numbers. So if you see, out of 9 digit elements that that can range from 1E 9 digits. Okay, so 1E8 till 1E9 minus 1. In this much large range, only 18 digits are possible. And similarly, if you see from 1E9 till 1E10 minus 1, only two numbers are possible. And after 1E10, like any number greater than 1E10, zero are possible. So if you see, there are very less numbers that are themselves good. Okay. I'm not talking about this whether their sum is good or not, but the numbers who themselves are good, they are very much less. Okay. You can calculate further, like they are very very much less numbers that are themselves good. Okay, when I thought about this, I first of all calculated like how many numbers were there. So there were very less numbers. Okay, so we can store the number that are themselves good. You can store them. So there is no problem for checking the numbers that are themselves good because they are very less numbers. You can see like from 1E8 to 1E9 minus 1 only 18 numbers. From 1E9 to 1E10 minus 1 only 2 numbers. Similarly, if you see the numbers will increase, but they won't increase that much. Okay. So That is why you can store the numbers, that are themselves good. You can store it. So this is the first observation. So what I'm saying is, you can store all the numbers from 1 till 1e15 that are good. You can store them. They won't be much large. Okay. So one of the things that is to consider is this. Okay. So this will help us, in calculating, like, so now you are given some L2R, and you want to calculate the fancy. Fancy was either it is itself good, or its sum is good, digit sum is good. So this part we have figured out. Like itself good, we can calculate very fast. Okay. How? You can do a lower bound. Like, see, you are given an L and an R, and you have an array. And in this array, you have to find how many numbers are between L and R. You can calculate it using lower and upper bound, lower bound and upper bound. Okay. So this you can calculate how, like how. See, I think you should know this from the binary search also, like how when we are given an array and we have to find, like, this is a store array, suppose store array, and when we are given an array, and this is a sorted array, sorted store. When we are given a sorted array, just let me check whether recording is playing or not. Yeah. So when we are given a sorted array, a sorted store, and we have to calculate how many numbers in this array are between L to R. You can calculate it using lower bound and upper bound functions. Okay, so this part is done. But how will we check whether the digit sum is good or not? Because digit sum would be repeating. So see, we have numbers from 1 till 1e15. What is the maximum sum of digits we can get when all the 15 digits are 9? So 135 is the maximum sum and 1 is the minimum sum we can get. So from 1 till 135, only the digit sum will remain from this range only. Okay. Like the digit sum will remain in this range only. But the numbers can be very large. Like there would be many, many numbers which have the total digits sum as 10. Okay. Similarly, there will be many, many numbers from 1 till 1e15 who have total digit sum as, 15, 20, or whatever. So calculating the digit something, it will be very time consuming. So what we need to do, like what we can do. So see, whenever you have to calculate like things based on some, like you are given a digit, and you have to construct the answer digit by digit, or you see a repeating pattern. Okay, so think of digit DP once, digit DP. It is, so this is the prerequisite also for solving this question. Prerequisite. You should know digit DP. Okay, so before doing this question, you should have an idea of digit DP. Then only you will be able to think about this question. Otherwise, doing it first time, and if you don't know digit DP, then thinking about it would be difficult task. Okay, so yeah, this is one of the thing that you should know. So yeah, so let's see how the digit DP will be applying here. Okay. Actually, it will be very standard only. Like major part was done here only. Like when you find this thing, like when we observed that we can store the numbers, the digit DP part is very much standard, and calculating the numbers that are themselves good is easy part. Okay. So that we have already figured out. Only we need to, check for the digit sum. Okay. So how will we do that? Like we will do a very standard digit DP. And since, in digit DP, I believe we should go like recursive approach. We should have a recursive approach. It is better than tabulation. So I have done tabulation. Oh, like a recursive approach only, like the memoization part. Okay, so let's see how the digit DP goes. Yeah. So what we'll be going to do is see. First of all, um, just as let me show you with the help of code, because that will help you better. Like because it is a very standard, like if you know digit DP, you can very easily see this, because it is a kind of standard template on digit DP. Okay, see, this is the function that is taking this index value and current sum value. Okay, and we are calculating, like in this question, like in this function, we are calculating how many numbers uh, are good in how many numbers are good, how many numbers are, I would say, not good, how many numbers are there whose digit sum is good, how many numbers are there whose digit sum is good from 1 till x. Okay, like the number was x, so the number was x. For x, like for x, we are calculating how many numbers are there whose digit sum is good from 1 to x. Okay, so we are calculating this in this function. So how we are doing that? So we are doing that in this way. Like, see, we have stored it in the form of a string so that we can iterate step by step, and for better implementation, I would say. Okay, so if the idx, like, see, suppose x contained how many, like x contained 5 digits. X was 5 digit number. So we have to calculate how many numbers are there, like whose digit sum are good and its value is from 1 to x. Okay, so for this value, suppose x was what was your x? 5, 7, 8, 1, 4. Okay, so suppose this is a 5 digit number x, and so the value here, like the value at this index can range from how much? Like it can range from 0 till 5. Okay, it can range from 0 till 5. And based on this, like suppose if the value is 0, we will have some sum, like the sum was 0. Forget about this part, like currently forget about this part. Okay, and see only this. Like if we put a 0 here, then the current sum is 0. If we put a 1 here, current sum is 1. And see, if we put a 0, 1, 2, 3, 4, anything over here, like if we put anything from 0 till 4 here, we don't have any bound on the number that we are going to put next here. See, if we put 1, we can put a 9 here, we don't have any problem. We can put a 8 here. If we put 4 here, then we can put 9 here also, like 4, 9, and whatever here. Like we don't have a bound. If we put over here like any value from 0 till 4, we don't have any bound. But if we put a 5 here, if we put a 5 here, then we can't put any value greater than 7 here, because already 7 is present in x, in the second place. You can't put a 5 8 or a 5 9 here. Okay. So this is the digit DP part. Like this, you should know beforehand. Then only you will be able to understand what I am saying. Like this is the bound part I am saying. So like we have a limit over here. We have a limit. Always we have a limit. Okay, so this is what I'm doing here. Like, see, if the IDX reach the end of the string, like then I am checking like whether the current sum, this store to stores, like whether the current sum it is good or not. Okay, this is what it is storing. Like if the IDX becomes equal to s dot length, then it is storing whether the store to is it is good or not. Like the current sum is good or not. This is returning that. Okay, if the current sum is good, then it will return 1, and otherwise it will return false. Okay, and now we are checking like the standard template. We are checking. Let me explain you the state also. Like what is the state storing? The state is two things, like dp of index comma current sum. And most of the times in digit DP, this is the state only. Whenever the things like sum or anything like that comes, most of the times you will see that the digit DP contains this as the state. Okay, so yeah. Uh, what does this index mean? Index means like we are considering it as an array of integers. Okay, the number was some int, and we are considering it as an array of integer. You can think like this. Okay, and this is the index from 0 up till whatever the value is, like 0, 1, 2, 3, 4, 5. Okay. And the current sum is, what is the current sum up till here? Like suppose we are on 2, like we are asking for 2, and what is the current sum up till here? So this is what we are storing. Okay. So this is what we are going to do. So yeah. So this is what dp of index comma current sum means. Like if we are not on limit, and I hope you should know this format, like we only return this if we are not on limit, and dp of index is not equal to -1, then just return dp of index comma sum. And otherwise we try on keep on putting the value based on the limit. Like here anything can come from 0 till 9, like from 0 till limit. Okay, and again here anything can come from 0 till limit, and we are trying and putting all of the values. Because see, uh, if we have already calculated, like see, suppose from these two values, the current sum came out to be 10. The current sum came out to be 10 and limit was 0, like on limit, it was not on limit. Okay. Sometimes you also refer to it as tight, I think, if you know that template. Like if it is not on limit and the current sum is 10, like making the current sum as 10, you have many different ways. Like the first two digits can be 2 4, like it can be 1 9, it can be 1 2 8, it can be 3 7, it can be 4 6, so it can be anything. But if the current sum is 10, the answer for the digits ahead won't change. So that is why if we have calculated the answer for these two and you are not on limit, so it becomes a repeated sub problem to calculate again and again. Why? Because see, current sum of all of them is 10. Current sum of all of them is 10. If you have calculated current sum is 10 here, like if you have already calculated, if you are at standing at index 2, if you are standing at index 2 and the previous digits current sum was 10, and you calculated the answer, so you only care about the current sum only. Okay, you don't care whether it is 192837, whatever it is, till the fact like it is not tightly bound. Okay, if it is tightly bound, then the case is different. Otherwise all of these here, they are not tightly bound in case of this number, 578, whatever it was, 57819, whatever it was, I think 814. So whatever was the number, we don't care about, as long as it is not tightly bound, as long as it is not tightly bounded. Like the index 2, as long as it is not tightly bounded, you can simply check for current sum. You don't care whether it was 19, whether it was 28, whether it was 37, whether it was 46. We don't care about that. Okay. So that is the reason. So we are taking the that is the reason we are taking the state as current sum, because we only care about that. Okay. So I am checking like whether this current sum can become this good or not. Okay, so that is why I am putting each and every value at each step. I am putting each and every value whatever I can put. Okay, such that it remains within bounds. Okay, so it should be less than equal to L. I am trying and putting each and every value such that it remains less than equal to L. Okay, so I am again saying that for in order to understand this part, like this part, you should have to know digit dp, otherwise you won't be able to understand it. Okay, so yeah, so I'm using like at the current index IDX, like in the current index where I am standing, I am trying and putting each and every value I can get. Okay, and based on that I can put the value from I equal to 0 till new limit, and based on that I am updating my current sum, and whether or not I am if we are on limit and I is equal to new limit, like uh see, your number was 57814. Okay. So now if at the end you are constructing a 5-digit number, so if you have put a 5 here, then you are, on the limit. Okay. And now if again you have put a 7 here, then again you are in the next index, you are on limit. Okay. So that is the thing we are checking here. If on limit and I is equal to new limit, you have to put on limit equal to true, and otherwise you have to put on limit equal to false. Okay. And finally I am storing it in the dp of index comma current sum, like I am updating my memoization table and returning the answer. Because the answer can be the sum of all states, like you can put a 1 here, like see, so see, you can put a anything from 0 up till new limit. So I am calculating, if when I put a 0, what is the answer, plus 1 plus 2 plus 3 up till new limit. I am calculating the answer for that. Okay, so I am doing like this. At each digit you will be having same thing, like at each digit you can put value depending upon what is the limit. Okay, So that is what we are going to do. Because see one thing, like what I meant to say is if you don't have a digit DP idea, like you can take an idea like this. Okay. See, your number was 57814. Now see carefully. Like if you don't have a digit DP idea, then only like for those I am telling, like see, if you put 0 till 4 here, if you put 0 till 4 here, the current sum will depend, like current sum will, can go from 0 till 4. Like if you put 0 here, current sum was 0. Forget about this part. If you put a 0 here, then the current sum is 0. If you put a 1 here, current sum is 1. And similarly up to 4, like if you put a 4 here, the current sum is 4. If you put a 4 here, if you put a 4 here, the value after that can take any value. Okay. Like it can go from 4000 till 4999999. Okay. So you have to consider all digits. Okay. So the sum will go for this, like for this part, for this highlighted part, the sum will go from 0 till 9 to 4, 36. Okay. For this part, the sum will go from 0 up till 36. Okay. It doesn't matter what you put over here. Okay. If you have calculated the answer from 0, like the digit sum from 0 up till 36, for all of them you have already calculated the answer, then you don't care whether 4 was here, 3 was here, 2 was here, 1 was here, or 0 was here. Because this part will go from 0 till 36 only. But if you have put a 5 here, then this part can't go from 0 till 36. Like this current sum can't go from, okay, this is possible. But the last number that is possible, it is 7814. Okay, so this is the last number that is possible if you have put a 5 over here. Okay, so that is the tight bound that is checking, so that you remain within the bounds. Okay, you remain within the bounds. That is the tight bound thing that is checking. Okay, so this is the main part. Okay, so let me show you what is happening. So, this is the pre-computation thing I am doing, just as I told you. Now, let me show you how will I, construct and, store all of the pre-computation thing. So, for that, I have, taken a BFS-like approach. Like, see, we have to either form strictly increasing or strictly decreasing. Strictly increasing or strictly decreasing. Okay. So for strictly increasing, think like this. See, suppose I put a 1 here. Initially in my queue, I will have 1 till 9. Okay, 1, 2, 3. Like these are not the number, they are independent. 1, 2, 3, 4, 5, 6, 7, 8, 9. I put all of these number in my queue initially. Now 1. After 1, what I can put? 2. 1 after 1, I can put 3. After 1, I can put 4. So after 1, I am trying and putting all of the values from 1 up till, 1 till 9. Okay. Similarly, when I encounter a 2, this is for increasing sequence first. This is I am doing for increasing sequence. Okay. Now when I see a 2, now after 2 I can put 3, 2, 4, 2, 5 till 2, 9. Okay. After after this, after 1, 2 I can put a 1, 2, 3, 1, 2, 4, 1, 2, 5. Okay, so this is how I am going to construct a element. Like at each index, like I will check the previous index, and I will I can insert values only starting from this up till the next number. So uh from 1 to I can only the next digit, like if I have 1 2, the next digit can be minimum only 3. Like 1 2 can't come here, only 3 can come for forming an increasing sequence. After 1 2 only 3 can come. Okay, and the value can range from 3 till 9. Okay, so this is how my BFS approach will be going to look like. Similarly for decreasing, first of all I will push all the element from 1 till 9. Okay, and after that, like see 3, suppose if the first element was 2, if the first element was 2, okay. After 2, what can be the next element that is coming? It will be 1. Okay, 1 can only come, or 2, 0 can come. So from 0 till 1, only two integers can come over here. Similarly, if the element was 3, anything from 0 to 2 will appear here. So suppose 3, 1 came. After that, only 0 will come. If 3, 2 came, anything from 0 to 1 will come. This will give you another two numbers. So this is how we are, forming all of the numbers that can be formed. So this I am doing using pre-computation. So initially, I am checking each digit sum also, like I am storing the digit sum, like whether, because the digit sum was ranging from 0 to 135, just as we saw, and I am storing whether the particular digit sum is good or not. Okay, I am storing it. This is like this part I will tell you later, but see this first. uh, this is the queue. I am storing all the numbers from 1 till 9, and because the first integer can be from 1 till 9. Okay, and after that, the standard BFS part, where the next digit I am putting from 0 up till the next number. So this is forming the decreasing part. This is forming the decreasing part, and I am pushing the number current into 10 plus I. So this is the next integer that can be formed. This is the decreasing part. Okay, this is we are forming the decreasing part. Now again, I am pushing from 0 till 9, like from 1 till 9 I am pushing, and this time I am going to form the increasing part. Like this is the last number of the current value, and plus 1, like whatever the last number of the current value was, I have to put anything that is greater than it. Okay, so this is forming the increasing part. So finally, I am sorting the store. Why I'm sorting? I'm sorting, to calculate that lower and upper bound, so that I can calculate the numbers that were themselves good. Okay, so that is the reason. So this is one of the part, like this was the part where, I'm storing the numbers that are good. Okay, these are the numbers. And I have already told you how to, calculate all of the numbers they, whose total sum is good, like whose current sum is good. So this I can calculate using this part. Okay. And finally, this is the main function. So see here, I have calculated the lower and upper bound, and this idx 2 minus idx 1 plus 1 I am calculating. So this is that part, like the numbers that are themselves good. And finally, this is the value. Like see, our solve function was calculating the answer from 0 up till x. Okay, and we want to calculate the answer from L to R. So you can simply calculate solve of R minus solve of L minus 1. This is also, a digit DP thing, like, or you can, this is also a standard trick, like whenever, if we have the answer from 0 till X and we want to calculate answer from L till R. So simply, calculate the answer from 0 till R and subtract it from 0 till L minus 1's answer. So this gives you the answer for L till R. Okay. So that is why, like, see, S2 is the string for R, and S1 is the string from L minus 1. So I am doing a plus of S2 and minus of S1. Okay, like plus of R and minus of L minus 1. So this gives you the answer for 0, like this gives you the answer for L to R, like the number of integers. This part, like this highlighted part is giving you the answer for L to R, like the numbers from L to R who have uh, digit sum good, because they were also, you know, a fancy, like what was the definition of fancy? Either themselves are good, okay, or their digit sum is good. This was what we observed. Okay, so the digits like themselves are good is covered using this part. Okay, IDX2 minus IDX1 plus 1, and themselves are like their digit sum is good is covered using this part. Now, if you see, there will be several numbers, like, you know, uh, there will be some numbers, like I have calculated this individually. Like you should know, like this principle of inclusion and exclusion, like A union B is equal to NA plus NB minus NA intersection B also. Like you can think like this. Some numbers, they are themselves good. The numbers that are themselves good, I have summed that. Okay, so you can consider it as NA. The number that are whose digit sum is good, I have calculated that. But there will be some numbers who are good, who are themselves good. They are themselves good, plus their digit sum is also good. Okay, so they are calculated twice. Okay, so they are like I have to for fancy numbers. I had to calculate the numbers they are that are themselves good, and I had to calculate the numbers whose digit sum is good. Okay, I calculated both of these and I added them. but there are some numbers who are themselves good also, and their digit sum is also good. Okay, so I have to subtract it because these kind of numbers are added twice. You can think of like them like this. There are some numbers A, like they are themselves good. These are numbers they are themselves good, and they are numbers whose digit sum is good. Now see, this part is common, and we have added this twice. Okay, so we have to subtract this part once, so that we don't overcount. Okay, so how we are subtracting this? Like I am iterating over the whole store. What is the store? This store is storing the numbers that are good. Like uh, what we consider like what we created like in the store. We were storing the numbers like see here. We were storing the numbers now here. The store dot pushback current like we are storing the numbers that are good. So store contains all those numbers. Okay. So what we are doing here is I am iterating over the whole store because we know the store doesn't contain too much elements. I'm checking if store is greater than equal to L and store is less than equal to R. Then I am checking its digit sum. Now if the digit sum is also good, then I am doing a subtract plus plus because I have to subtract it. Okay. So that is the reason. And finally, I am subtracting the common part. Like these are the numbers that were themselves good and their digit sum was also good. Like this common part. This common part I am subtracting once so that I could have got the correct answer. Okay. So actually, I can't run the code because the question is like this is the exact code that I had submitted, but I am not showing you by running it because I don't have the internet. It will show network error. So that is the reason. Uh, I hope you are clear. For this question, you should first know the digit DP part, then only you will be able to understand because the digit DP part is very much standard here. It is extremely standard part. You don't have to think anything like if you know the digit DP, you could easily have solved the digit DP part. The only thing you need to consider about this is this part, like calculating the numbers that are themselves good and this part was also easy. Why? Because once you know that the numbers are less who are themselves good, then you can easily calculate this part also. Okay. So yeah, that's it. I hope you are clear. Thank you.